In the stillness of the early morning hours on November 19th, a quiet alert blinked to life inside NASA's Deep Space Tracking Center. The source? A minor fluctuation in the pulse tracking algorithm used to monitor interstellar bodies. It wasn't the kind of data that triggered alarms, no explosion, no impact. Just rhythm. But not just any rhythm. This one repeated with uncanny precision once every 271 seconds.
For nearly 11 minutes, radio receivers recorded a consistent, measurable signal. Not random, not noise repeating at precise intervals. The signal's origin appears to coincide exactly with the path of 3I Atlas, which is now leaving the inner solar system.
At first, the anomaly was thought to be a software artifact, a glitch, a cosmic coincidence. The system was rebooted, filters were reapplied, yet the signal remained. And that's when someone at JPL picked up the phone and called Harvard. Within hours, Avi Loeb had the data in front of him. He didn't blink. He leaned in.
Well, what we see are 7 jets coming out of these objects, more than 7 actually, after it passed close to the sun on October 29th.
The waveform didn't just repeat. It carried something else, modulation, a soft pattern embedded inside each peak and valley. Hidden beneath the obvious signal was a faint secondary pulse, almost like a fingerprint. Not strong enough to transmit information in any traditional sense, but consistent, regular, precise. "This isn't random," Loeb said quietly. "This is information." What made it even stranger was the directionality. As telescopes from Chile to Australia tried to pinpoint the origin, the beam aligned consistently with the ecliptic, the plane of Earth's orbit. The beam swept across our position like a rotating lighthouse, not flaring out in all directions but targeted, narrow and deliberate in its motion. The implications were immediate and disturbing. Either we were witnessing a natural phenomenon unlike anything we had ever seen before, or we had just intercepted the echo of something designed, something ancient, something still functioning. And in that moment, scientists realized this wasn't just a new discovery. It was the beginning of a new category. As additional telescopes locked onto 3I Atlas, the signal's properties became clearer and more confusing. The light wasn't diffused in all directions like typical comet reflections. It was collimated, compressed into a tight, coherent beam, more like a laser than sunlight bouncing off frozen dust. Most celestial bodies scatter light in all directions. Comets, especially, are known for chaotic tails and unpredictable brightness. But 3I Atlas's emissions weren't chaotic. They were disciplined. The object rotated every few hours, and with each rotation, the beam returned to sweep over Earth's position. Not broadly, but narrowly, within a corridor no wider than 2 Earth diameters. Observatories across the globe confirmed the pattern. From Mauna Kea to the Very Large Telescope in Chile, and even the ESA's solar orbiter, the light beam maintained its integrity across millions of kilometers. That coherence stunned engineers. Atmospheric distortion usually breaks up signals like that. Yet here it was, straight, sharp, pulsing. Loeb's team analysed the spectral composition. The beam wasn't just bright, it carried a unique fingerprint. Inside its light were absorption lines inconsistent with common comet materials. There were no standard water vapour traces, no dusty carbon smears. Instead, hints of ionized nickel, rare earth elements, and something even stranger, flickers of modulation in the ultraviolet band. Buried within the beam was structure. Not Morse code, not binary, but rhythm. A repeated signature that pulsed not just with light, but with intention. Not speech, but presence. The implications were staggering. Was 3I Atlas sending a signal, or was the light simply a byproduct of some internal mechanism, like the cooling system of an alien reactor? Nobody could say for sure. But one thing was already certain. Natural objects don't point light at planets with that kind of regularity. Something, whether machine or mystery, had just revealed itself. When NASA's Solar and Heliospheric Observatory released updated composite imagery of 3I Atlas, most astronomers expected confirmation of a routine outgassing event. Instead, what they saw triggered a wave of private messages between research labs across the world. Jets, but not one, not 3, at least 7, and they weren't random.
Well, what we see are 7 jets coming out of these objects, more than 7 actually, after it passed close to the sun on October 29th. And we can see that some of these jets are pointed towards the sun, and they penetrate over 1 million kilometers through the solar wind.
Instead of curling away from the sun, as cometary jets typically do, pushed outward by solar radiation pressure, some of these jets were moving toward the sun, against the solar wind, against physics. That alone caused discomfort among solar physicists. The solar wind is a powerful stream of charged particles, constantly accelerating outward at hundreds of kilometers per second. For a plume of particles to push against that stream, something far stronger than sublimating ice would have to be involved. Moreover, the jets weren't diffuse or irregular. They were linear, straight, directed, almost engineered. They emerged from consistent positions on the object's surface. As it rotated, each jet held its direction, adjusting only slightly to match changes in solar wind density. Some jets curved gently, as if following magnetic lines. Others cut straight lines through space, ignoring all known forces. One particular jet, tracked for over 90 minutes, remained as stable as a propulsion exhaust from a maneuvering satellite. When Loeb's team ran mass ejection models, the numbers broke. For a natural object to produce jets of that momentum, it would need to expel billions of tons of mass in minutes. Yet 3I Atlas showed no signs of shrinkage, no fragmentation trail, no material loss consistent with that scale. 2 possibilities remained. 1, a non-thermal emission mechanism never before recorded in natural space objects. 2, deliberate propulsion. Either way, 3I Atlas wasn't behaving like a comet, it was behaving like a spacecraft, and that changed everything. Most cometary bodies have one thing in common: a porous, icy core. They're loosely held together rubble piles, cold relics from the solar system's formation. But when radar mapping data from NASA's Deep Space Network and ESA's tracking system was compiled, something in 3I Atlas refused to fit. It didn't echo like ice. It didn't scatter like porous rock. It reflected cleanly. The radar profile suggested high density, uniformity, and structure. Not chaotic, but layered. Initial models estimated the object's core had a reflectivity index closer to that of dense metal alloys than carbonaceous ice. And as more rotational data came in, it became clear 3I Atlas wasn't tumbling randomly. Its spin was stabilized, locked in phase with the positions of its jet emissions, as if some internal balance system was active. That's when Avi Loeb made a quiet note in his lab journal. We may be looking at a gyroscopic core.
Here, if we ever encounter alien technology, everything will change. And the intelligence agencies know very well that events with very small probability have to be considered seriously because they could have major implications.
If that was true, it would make 3I Atlas the first known interstellar object with internal momentum regulation, something only seen in engineered spacecraft. To stabilize an object that size, with that rotation rate, would require an internal mass structure precisely distributed. The simulations didn't lie. This was not the messy interior of a shattered ice ball. It was dense, controlled, possibly intentional. Further complicating the analysis, NASA's magnetometer readings showed fluctuations in local space weather patterns around the object, hinting at electromagnetic behavior. Could the core be charged, conductive, acting like a coil? If so, that would explain the interaction with solar particles, but it also raised the most haunting question yet. If this core is engineered, or even semi-structured, then what is its function? Because cores don't align themselves, they don't generate rotation locks, and they definitely don't survive eons in space without a purpose. So now we ask, what was 3I Atlas built to do? In astronomy, colour isn't just visual, it's diagnostic. The hue of a comet's tail reveals its composition, temperature, and energy state. Most comets reflect pale yellows and dusty greys, with occasional green traces from diatomic carbon. But when 3I Atlas emerged from behind the Sun, its signature colour was something else entirely. Bright plasma blue, electric green, hints of violet and a metallic red glow beneath it all. Spectral readings from the James Webb Space Telescope and ESA's solar orbiter confirmed it. These weren't colours seen in ordinary comets. In fact, they weren't seen in any known natural objects. Ionized nickel, highly energized carbon chains, exotic heavy metals like iridium and neodymium. The blue-green coloration strongly suggested an energized plasma interaction, something akin to artificial propulsion exhaust rather than sublimated ice. Even more troubling, the colors weren't static. They pulsed with the object's 271-second rhythm. That same interval, the one tied to the repeating optical beam, this synchronicity pointed to something more than chemistry. It hinted at mechanism, possibly even synchronization, like a machine adjusting itself in response to external forces. Loeb noted that some of these spectral lines are only reproducible under laboratory plasma conditions or in the combustion of controlled materials. One specific frequency spike was so unusual that it prompted reanalysis at 3 separate labs. One hypothesis emerged: the color isn't just chemical, it's procedural. That is, 3I Atlas may not contain rare elements. It may be generating them through internal processes. If true, it would explain the thermal anomalies, electromagnetic behavior, and the object's resistance to outgassing disintegration. The color in this case might not just reflect composition, it might reflect activity. Because when metal glows in space, something inside it is still working. Ordinary comets don't hold together well under pressure. As they approach the sun, they tend to fragment, destabilize, and eject volatile materials in unpredictable jets. Their cores, fragile and porous, can't withstand the thermal and gravitational stresses. But 3I Atlas was different. Despite emitting at least 7 high-powered jets and enduring extreme solar radiation, its structure remained stable, unnervingly so. As it rotated, there was no sign of precession or wobble. The jets did not push it off-axis. Its brightness curve remained clean and even, with no chaotic fluctuations typical of natural outgassing. That's not how dying comets behave. That's how balanced systems behave. ESA's solar orbiter recorded infrared images showing not only a solid rotation rate, but also minimal mass displacement. That means the object wasn't losing material at the scale expected for the jet velocities being measured. Then came another anomaly. Its coma, the diffuse cloud of gas and dust surrounding a comet's core, was almost non-existent. Instead of expanding outward chaotically, it remained tightly bound around the object like a magnetic halo. Some scientists proposed that 3I Atlas might be surrounded by a charged electromagnetic field, strong enough to contain dust and even plasma emissions. If this were true, it would resemble not a comet but a plasma containment vessel, the kind used in Earth-based fusion experiments. Loeb suggested that if the object is artificial, its apparent coma might not be a natural byproduct, but a controlled system, perhaps even part of its navigational shielding or heat dissipation. This level of dynamic balance doesn't occur naturally, not across millions of kilometers of acceleration and solar exposure. If 3I Atlas is resisting chaos, then it may be designed to survive chaos, and that changes its classification forever.